everyone. Hi, everyone. Thank you so much for being here today. I really appreciate it. So I want you to all think about your journey here to this room today. When you were walking through London, perhaps you were flying in from somewhere else, and when you were walking around, all of the people, the noises, the tourists, the obstacles. Now imagine all of that if you were blind. What would that be? Suddenly having all of these sounds. A curb is no longer a small thing. It becomes a danger. It becomes a hazard. It becomes something terrifying. Perhaps that's why over 160,000 people who are vision impaired in the United Kingdom do not leave their homes. But there's a solution. Guide dogs. Very easy. Guide dogs are not pets, they are partners. They are in a mutual relationship with the people that they serve. However, guide dogs are not that easy to make and train. So it takes 2 years to train a guide dog and costs about $50,000. And after that training, they do work with their partner for 6 to 7 years. However, after that time, the guide dog has to be retired because you don't want a guide dog to also be going blind themselves or to have physical impairments or get cancer or diabetes or Alzheimer's. All of those would be very bad for a dog. And so this is an incredibly, both technically and emotionally challenging time for both the guide dog and their human. Their humans, the ones we've spoken to, say it's very close to losing a spouse. Just let that sink in. Every 6 to 7 years, they have to go through this heartbreak. And it's not because the system is broken. It's not because there's anything wrong. It's because dogs simply don't live that long, which is what our solution is. We want to extend the lifespan of dogs. We are using gene editing techniques of CRISPR-Cas9 and a suite of longevity genes to increase the lifespan of dogs. And this is an absolutely revolutionary time in science, in that this CRISPR is akin to the printing press. So before, all of us in the lab were slaving away, similar to scribes trying to transcribe the Bible to get this one edit. And now you can do it all in one step, and not just in a single cell, but you can actually do it in a living organism. And that is absolutely a game changer. And so what this looks like for us is that everyone knows about lifespan, right? It's the number of years you live. But health span is also the quality of those years. So normally you have youth, middle age, and morbidity. And in dogs, that's typically about a third for each. In our gene-edited dog, the Forever Friend, you have a much longer lifespan, but you also have an increased health span of youth and middle age. That morbidity period is so short that diseases like cancer, Alzheimer's, diabetes are things of the past. And so for us, the big innovation is that we take this enormous power of CRISPR and we marry it to the world of longevity. So quickly, this graph, this was some research I did about a decade ago, and it shows that in the red, those are the wild-type normal organisms. The ones in blue are ones that we have modified with a particular gene, and then we expose them to some really acute radiation, like 600 times the strength of a sunburn. And that is the power of that gene. And that gene doesn't just help you from acute radiation, it also helps you with different types of stress, oxidative stress, heat, cold, disease, viral and bacterial. It's quite remarkable. And so what we are doing is bringing these two worlds together for the first time to double the lifespan of man's best friend. And so you're thinking, wow, why you? Why now? So for me, as I mentioned, I've been doing this for a while. I'm very obsessed with aging. I was at UC Berkeley doing research there. And more recently, I've gotten an MBA at Oxford. And one of the benefits of these great institutions are you meet really smart, really amazing people. And so here's my team, and I'll just introduce you to a couple. So we have Stephen. He is a doctor in molecular and cell biology with a focus on biochemistry, biophysics, and structural biology. He is also got his PhD in the lab that invented CRISPR. So he is one of the best in the world at this technique. Then we have Etchem. She is the head of our ethics area. And this is really important because if you're having this moonshot of, ending death, this is something that's going to be changing. And so she, Etchem, feel free to raise your hand, is here focusing on what this means for humanity. And then we have Arjun, who's in charge of our finance and operations. And Arjun, feel free to raise your hand as well. He's here tonight, and I'm going to show you some of his work now. So in terms of market size, if we just think about hero dogs, so those are military dogs, service dogs for the blind that we spoke about, each of those costs between $50,000 and $300,000 to train, and also use between 2 and 5 years to do that training. So to increase that lifespan, that working lifespan, like double to triple, is really remarkable for those industries. But then you also have the mass market, which is over $100 billion. And of course, human trials as well, potentially in the future. So if we think about what does this mean pricing-wise, we're looking at, after we have our first litter of dogs, that we're looking at between 5 and 16 million in revenue that first year. And when we move into the mass market, that becomes billions year over year. So I want to just thank all of you for coming here today, and I especially want to thank KK and the Seedland team. This has been really amazing, and with your help, we can revolutionize aging, revolutionize disease, and bring our first litter into reality. Thank you.
Incredible, ending darkness. Judges, what do you have to say?
Can I start?
Yes,
I'm probably going to be devil's advocate again.
Please.
Okay, so this sounds really expensive and difficult. Surely the only way you can figure out if it kind of works is if you've raised several litters of dogs and had to raise them until they die, and you've seen them live their lives. So it seems to me the testing process is quite lengthy, in which case, what's wrong with the old-fashioned way of doing it? We've been selectively breeding pets, cattle, crops for thousands of years.
Sure.
Could we not do the same for dogs?
No. So let me answer your question in two parts. So the first is, this seems expensive. It's going to take a long time. Why this? Why now? Right? And then the second is, why couldn't we just do selective breeding? So the first part of the question is, that's why we're really interested in these highly trained dogs, particularly in the military, because that's a place where part of our contract and part of our model is every year we check up on the dogs. It's very similar to if you have high-end machinery, that you have a service contract where people who sold you that tractor or sold you that whatever, go and make sure that the machinery is okay every year and fix the things that are not. And so that's part of the contract. Especially, it's very easy if you're working with the military to continue that process. So we can watch those dogs over the course of their lifetime while they're still serving. So that's sort of part one of how do you monitor. This would take a long time. So what we're doing that, we can also be generating.
I didn't ask how you monitor it, because monitoring is not the problem, right? The problem is to figure out if they're going to live a long time. You've got to see whether they live a long time.
Oh, absolutely.
And that involves time, right?
Oh, absolutely. So in this case, it takes you, a Navy SEAL dog costs $300,000 to train. It takes 5 years to do that training, right? So from puppy through 5 years, we're training, we're watching, we're doing. But then that actually Navy SEAL dog is only able to serve for 3 to 4 years. We also continue watching and monitoring that dog for 3 to 4 years. Anything beyond that is gravy, right? Anything beyond that dog would have been retired already. And so that's where we're continuing to watch. Oh, okay. Oh, look, that dog worked for 5 years. Oh, that works for 6 years, right? And we also build that into our revenue model as a way to have both parties be incentivized to make sure that this dog is going good. So that's sort of to your answer. And then your second question was, why not just do selective breeding? And I think that that's really important because, yes, we all have great genes and that's fine. However, the thing about this particular format with CRISPR, it's not just 1 or 2 genes. It's that we can actually, we're looking at a suite of several genes in this process. And so it is very unlikely if you're doing selective breeding to get all of these together. And some of them are innovations that actually you cannot do selective breeding because they interfere with the reproductive ability of the dog.
Thank you very much.
Yeah.
Thank you very much. Big applause.